So, hello to episode 3, and as usual, we are starting off with a demonstration. This small episode is going to be about designing a basic graphical user interface for the Subtractive Synth. So we are deviating a little bit from the path of continuing to build the synthesizer components, but rather have a look at the graphical user interface. So the basic graphical user interface for a Subtractive Synth. We are going to show it right now, and as you could imagine, you will find very many very interesting user interfaces when it comes to synthesizers. One of the cool parts about designing synthesizers is indeed thinking about the user experience and the usability. So we are relatively free to design our stuff, but some conventions, at least for subtractive synths, have emerged over the years or decades, and in order to, let's say, follow these steps, we are going to take inspiration by an existing synthesizer, which I actually own, which is the Moog Werkstatt. And the Moog Werkstatt has been released about 9 to 10 years ago, so in 2014, and I bought 2 of them in order to build them together with the students within a course. So this is a DIY synth, a very simple synth, and it has been specifically designed by Moog to be used in educational purposes. So if we look at the Wikipedia, once again, there's a very short thing about the Werkstatt, just Werkstatt of 1 educational tool and analog synthesizer from Moog. And the obvious reference that you find in the name is, of course, related to the German word Kraftwerk. At least that's how I understand the name here. So Werkstatt, German word for workshop, is a subtractive synth. If you have a look at the website of Moog, we still find information about the Werkstatt, but unfortunately it is no longer produced. But nowadays you can buy the Moog Mavis, which is the ancestor, the predecessor, what is it? Well, it's the later version. Sorry, missing the English word here. All right, and as you can see, there's an expander here which you can put a stick onto the stuff. And the reason why I've been kind of like waiting for producing another video is just the case I was searching for my expanders and I simply can't find them. I think I've lost my expanders, which is terribly sad, because they really help using the system with my other gear together. So I'm still hoping to find them, but I guess when moving my office, I think I've somehow lost them. Well, anyway, this is the Moog Werkstatt, and this is the interface that we are looking at. So, as we can see, the system consists of a VCO, a VCF, and a VCA, our standard components of a subtractive synth. But it also has got parts where it can do some modulation. So the VCO can be modulated and the VCF can be modulated. And as you can see, we've got 2 sources of modulation, namely the EG, the envelope generator, which is down here, and the LFO, the low frequency oscillator, which is down here. Same holds true for the VCF. Again, we can switch between EG and LFO and use either this or this one. The amount is then scaling up the values, and when it comes to modulation, we've got 2 destinations, which is the pulse width. So when we've got a pulse wave here, we can modulate the pulse wave, and if we switch to saw, we can modulate the frequency. Okay, you can also modulate the pulse width by hand. So if you switch down to frequency and then turn the knob, the pulse width of the pulse is going to change. All right, and up here on the VCA, we've got 2 options. The first option is to use the envelope generator to control the VCA, mainly to control the loudness, or in order to kind of like do constant creation or do constant drones, we can simply switch it to on. Then the VCA is going to be on all the time, so all the time you will be having sound. Okay, and eventually have a short look at the envelope. The envelope, as you can see, has an attack and a decay, so it's not an ADSR, it's just an attack decay. To be more precise, it is an ASD, or ASR. How should I put it? Well, anyway, you can put switch to sustain off or on. So if you switch it on, as long as you press the key, the sound is going to play, and the decay is then going to be the release time. So once you release the key, the decay phase is going to happen. So basically, it is an ASR envelope or an D or A R envelope. And eventually, finally, the LFO. The LFO can be is an oscillator, and the rate can be switched, the frequency can be switched, and it goes all the way down to almost zero, and it also goes all the way up into the auditive range. In other words, it goes beyond 20 hertz, and therefore you can realize some frequency modulation with the system, at least a little bit. All right, and you've got two waveforms. One is the triangle, and the other one is a square. The square is quite interesting because it jumps from 0 to 1 and then from 1 to 0. And by using the square, you can kind of like move the frequency, for example, of the VCO going up and down and up and down and up and down in a specific interval that you may define with the amount here, which is quite interesting. So triangle is obviously more smooth. It goes like this, almost a sine wave, but it goes like a ramp up and a ramp down. And by this you can control, for example, tremolo or vibrato will be possible. And as usual, we have the fantastic Moog filters. It's a low-pass filter, and you can set the cutoff frequency and the resonance, and therefore you get this very specific Moog sound. So it's a relatively simple synthesizer, yet you can generate very interesting sounds with it, and especially if you combine them, you get this very typical vintage soft analog sound that you are used to when you're talking about Moog. Okay, and down here you see a little keyboard. This little keyboard is just keys that you press and so on off. So obviously there's no kind of like velocity or anything like that. And in addition, you can turn on glide or portamento or the portamento. I don't know what's the plural. Ask Alex Ball. He doesn't know it anyway. And glide. So going down from C to C, it will glide all the way up, and this is the time that it's going to take to glide from one node to the other one, which gives some very nice effects. All right, let's go over to our Super Collider, and as you can see, the code is much longer right now. Defining graphical user interfaces is a tedious work. It basically means that you have to define all the components that you see on the UI, and all in all, we can now see that it's almost 271 lines that we have to code. Nevertheless, the code in its structure is very simple. Now let's have a look. How does the user interface look like? So if I'm starting it off, there we go. So what we get is a window, and this window, sorry for this. This window is relatively simple, similar to what we see here. So you see, I've taken my labels, and I turned Moog into Moog, just in case I'm going to get into some trouble here. And we've got the usual knobs, and we can kind of like turn the knobs. And as you can see on the right side, we again have this principle of callbacks. So when I'm turning the knob, the value goes from 0 to 1. And this holds true for all the knobs. So just like that. And then the second thing we have multi-state buttons. These multi-state buttons are basically just like switches. So if I press the key, it switches from pulse to saw and going back. And as you can see, the callback function moves from 0 to 1 and back to 0. So depending on the state of the button, I get a value of 1 or 0. And this is the same here, and the same here, and the same here, and so on and so on. All right, so basically this is how the interface looks like. I think it's comparable. Let's say comparable. I don't say it's good, but it's comparable to what we see. So we can design interfaces relatively simple. We've got a number of possible graphical user interface objects like knobs and sliders and so on and so on. What I've taken here to design the stuff is the most simplest version. So there are more elaborate versions that you can actually use by using extension of SuperCollider, but I want you to use the very simple stuff which you will always find in SuperCollider. Okay, and down here I've got the keyboard, and as you can see, I marked it with the English names for the keys. Obviously, as we can switch the frequency or turn the knob on the frequency, the C won't be a C. It's just, well, coincidentally, it could be a C, but it could be any other key here. But okay, in order to mark them. So this one is a single state button. So the only thing that I do, I can press it, and as you can see, again, a callback function is called, and then I would react to it. Okay, you also see there's this blue border around it. I don't know how to change this. I didn't look too much into these kind of details, but as you can see, I can press the buttons. Yeah, and the glide button is glide knob is just a normal knob. So this is how the interface looks like, and in the theoretical part I'm going to have a little look at the code, how this is done and how we could set up these interfaces.